In a previous video to this, we looked at properties of quadrilaterals, we looked at parallelogram. I've got an example of this on this page, you can see. Also looked at properties of rectangles, squares and kite. In this video I'm going to look at properties of rhombus. So what is a rhombus? Well, here I've got an example of a rhombus right here. A rhombus is like a parallelogram. The only difference is that whereas with a parallelogram, opposite sides are the same size, equal in length. Like this one, for example, is equal in length to this one, and this side over here is equal in length to this side. For a rhombus, well, it's like a parallelogram. The only thing is that all four sides are the same size, right? So you could say all sides are equal length, or equal in length. So that's one statement. Another one you can say, something about angles, is that opposite angles are equal. Just like here, opposite angles, like this is opposite to this, it's the same size, and this is opposite to this, they're the same size, right? Here, exactly the same. This is the same size as this, opposite angles are equal, and then this one is equal to this one. So you write down opposite angles are equal. Another thing you can say is about the diagonals. With this one, with the parallelogram we looked at earlier on in a previous video, right, the diagonals bisect each other, cut each other in half. Well, the same thing happens with a rhombus. Okay, the diagonals cut each other in half, i.e. they go through the middle of each side, each diagonal. They bisect one another, but the only difference between this and the parallelogram one is that this is a special case where they cross each other at 90 degrees at right angles. Right, they're perpendicular to one another. So you can write down diagonals are of equal length and are perpendicular bisector of each other. Right, the definition of perpendicular and bisector we looked at in the previous video. Next we've got the trapezium. Right, I briefly introduced what a trapezium is in the previous video. A trapezium is basically like a triangle. So you've got a triangle like this with the top chopped off. Rather, the way you chop the top off, that this bit has to be parallel to this bit. So that bit gets chopped off. So that's your trapezium. Right, you could also have it this way as well. You can have a triangle lying on its side. Right, let's assume this is the top. Yeah, you chop the top off and make sure this line is parallel to this line, like train tracks. Right, that's a trapezium. Even if it's a right angle triangle, let's say you got a right angle triangle, you can chop it from, if you chop it here, you can chop it this way if you want. So that's your trapezium. That's one way of having the trapezium, or you can chop it the other way, this way. You can see this line over here is parallel to this line, so it's still a trapezium. Right, these are all trapeziums, and one thing you notice about the trapeziums, the sides. Right, there's one pair of parallel sides only, one pair. So this over here is parallel to this. This way these two are parallel, and you signify that using arrows to say these are parallel. Right, these two lines are parallel. So you could say trapeziums have one pair of parallel sides, and that defines a trapezium. Another way you can draw a trapezium is using this definition here. We know that for it to be a trapezium, one pair of parallel sides. So what you can do, just have any two lines, any size, that are parallel to one another, like train tracks. Right? They can be two different sizes. And all you're going to do now, you know this is parallel to this, right? All you're going to do now is join these up like this. That's a trapezium. You can have another one. Look, any two parallel sides. So this is parallel to this, and all you're going to do then is join it up. That's a trapezium as well.